All right, we're going to do the first part of the supplemental review, and we're going to look at problems that are all from Unit 1.3, and those are the first, really the first 4 problems. We'll see how many we can get on this video. Let's see, in question 1, we're asked to find the value of x. So remember that we need to know whether we're talking about, like, what type of angles we're talking about. We said that when 2 lines are parallel, that the angles that are congruent are going to be vertical, corresponding, alternate interior angles, and alternate exterior angles. The ones that are supplementary are going to be linear pairs, our same side interior, and our same side exterior. So we know that these 2 lines are parallel. The question is, what type of angles are these? Well, these are alternate exterior angles, and they are therefore congruent. So I'm going to say that 5x equals 4x plus 20. I could subtract 4x from both sides, and x equals 20. All right. Number 2, we're just naming the relationships here. So angles 4 and 16, if I look, angle 4 is right here, and then angle 16 is right here. And these lines aren't parallel, but the relationships still exist. So it kind of helps to cover up this other side and just look at this intersection here, these 2 intersections rather. So 4 and 16, those are going to be same side exterior angles. All right, then when we look at 6 and 1, erase that stuff. If I come over here, 6 and 1, they're happening at one intersection. It doesn't matter if I look at like these 2 lines, or if instead I look at these 2 lines and this transversal. It doesn't matter because 6 and 1 are vertical angles. All right, and then lastly, 14 and 16. Let's see, so if I look at this intersection where 14 and 16 is, and just kind of disregard the rest, 14 and 16, well, let's see, they're not, we can rule out same side interior or exterior because 14 is on the interior of the 2 lines and 16 is on the exterior. But if I look, 14 is in the bottom right of its intersection, so I could say that it's in the bottom right. 16 is in the bottom right. And when that happens, those are corresponding angles. All right, moving on to number 3. In question 3, we are now writing the equation of the line parallel to the line through a given point. So if I'm given this line and they're parallel, I know that parallel lines have the same slope. And I need to remember that perpendicular lines have opposite reciprocal slopes. So for this slope 4/3, if I was finding 4/7 as my slope, if I was writing the equation for the line perpendicular to that, I would need -7/4. All right, but that's not what I need for this problem. So I need my slope is 4/7, and this is my x and my y value. And so if I write my equation y equals mx plus b, I'm going to plug this in for m, this in for x, this in for y, and b is going to be what I'm left with. I'm not going to use this -3. So my y is 1. My m is 4/7. My x is -28. And I could stick a 1 under there if I want, just so it's a fraction, and then plus b. So instead of doing 4 times -28, I'm going to factor out a 7, which is going to change that -28 into a, what's 28 divided by 7, into a 4. So I'm going to make that a -4 now on top. So I just factored out that 7. So 1 equals -16 plus b, and then I would want to add 16 to both sides, and I get that b equals 17. So finally, I'm going to write y equals 4/7 x plus 17, And that's the equation of the line parallel to this line that goes through that ordered pair. All right, I do think we have time to squeeze number 4 on here. So these are all kind of the same topic. Number 4 says that line M goes through these 2 points and line N goes through these 2 points. We're asked to find the slope of each and decide if they're parallel, perpendicular, or neither. Remember that my slope is just my change in my y over my change in my x. We say rise over run on a graph. So if I make a table for line M, I'm going to make an xy table, like a t-table. I'm going to plug the point -9, 0 into my table, and then I'm going to plug my other point, -8, 2 into the table. And to find my change in y, I do need to pay attention to my signs, but from 0 to 2, y is increasing by 2. And then from -9 to -8, y is actually increasing, or sorry, x rather, is increasing by 1 because it's getting less negative. So my slope for line M is 2 over 1, which is just the number 2, and they're both positive, so positive 2. All right, so then if I do the same thing for line N, if I make my xy table, I'm going to put the ordered pair 3, 3 in my table, and the ordered pair 1, 4 in my table. All right, so if 3 to 4 is an increase of 1, that's my change in y. 3 to 1 is a decrease in 2, that's my change in x. So my slope of N is -1/2. So I know that these are not parallel because they're not the exact same. So the question then is, are they perpendicular? And remember, that was the same as saying like positive 2 over 1. So the answer is yes, they are perpendicular because their slopes are opposite. They have opposite signs and they're reciprocals. So back up here we said opposite reciprocal slope. All right, you are going to have to answer a couple questions in Schoology, and then you will have another video in the next part.